Hello, class. So today we're going to start chapter 2 and we're going to look at the concept of thinking like an economist. So the things that we're going to cover in this chapter are, well, we're going to learn what are the two roles of economists and how different are they. And we're going to learn what are models and how do economists use models to explain the world around us. We're going to see one model, an example of a model, which is called the production possibilities frontier, and we're going to see how it is related to the concept of opportunity cost that we learned in the first chapter. And then finally, we're going to see what is the difference between positive and normative economics, and also between micro and macroeconomics. These are the two big fields in economics, and so we're going to see what they are and how they differ. So the economist is a scientist in a way. So one thing that the economist actually has to decide is like what kind of role do they want to play. So they play two kinds of role in this world. One is that of a scientist, which is they try to explain the world as is. So if there is a data that they collected and that they analyzed, they make they're trying to explain the world using that data. So if I say that unemployment rate today in the US is 5.5%, there is a reason why that is, because I collected data to explain that phenomenon. It's not my opinion, it is kind of like the fact about the world. The second role that economist plays is that of a policy advisor, and where they try to improve it. So now that I know that unemployment rate is 5.5%, okay, is that too high or too low? If it's too high, then what should I do to improve it? What should I do to reduce unemployment? What policies should I implement? So, as policy advisors, they're trying to implement those steps that will try to improve the world. In the first step, that is, as a scientist, the economists actually do something known as, or they employ the scientific method, which is the idea of basically collecting data or developing a model that will be explained using the data. And using the data and theoretical models, the economists try to explain how the world works. So here we come to our next step, which is assumptions and models. Assumptions are those steps that we take to simplify the world that we work in. So it helps us to make it easier to understand what's going on in the world. So for example, if I want to study international trade, it's easier for me to assume that there are two countries and two goods. Well, there are more than 200 countries in the world, and millions of goods and services are traded between each countries. But to study that phenomenon would take a very, very complicated model that would be very, very difficult to understand. So instead of doing all that, we are just simplifying the model and just assuming that there are just two countries in this world and they just trade two kind of products. And the results we get from that model is actually simple enough for us first to grasp it, and secondly, it can be generalized to how the world is working around us. It is unrealistic, but it is very simple to learn, and it gives us very, very useful insight about how the real world works. So what we do next is after we created our assumptions, we create a model which is a highly simplified representation of reality. So it's an abstract version of reality. Economists use models to study different kinds of economic issues. They're simple enough for us to understand, but they are also good enough for us to explain how the world works. So one such model that we are going to learn today is the production possibilities frontier. So the production possibilities frontier is a graph that shows how two products are produced in an economy. So let's say a country or a society or a region can only produce two products, and the region has a certain number of resources available and a certain number of technology available. So the production's possibilities frontier just shows us what combination of the two products can be produced given the resources available and the technology available. So in our example, let's say that there are just two products, computers and wheat. Of course, this is very highly unrealistic. I mean, you don't have a region just doesn't produce two products, or a country doesn't produce just two products, but we're assuming that in this system, we just have two products. Computers can denote all the machineries produced in the system or in the country. Wheat can denote all the agriculture products being produced in the country. There's just one resource available. Let's say it's just labor. So we have a set number of labor hours available for production. And let's say that the economy has enough labor to produce a certain amount of goods. So let's say the economy has about 50,000 hours of labor available for production. So this is the model that we have. We have made some very simple assumptions. We just picked two products. We just picked one resource, which is just labor. And we just said that this resource can contribute about 50,000 hours per month for production. So now if we try to see how much to produce, now we need some idea about technology. So let's say that if we wanted to produce one computer, it would require 100 hours of labor. If we wanted to produce 1 ton of wheat, it would require 10 hours of labor. So basically, to produce one computer, I need 10 times more labor than when I produce 1 ton of wheat. So let's say we wanted to now see how many, given the 50,000 hours of labor that we have, how many computers and how many tons of wheat can we produce? So let's say we use all our 50,000 hours of labor to produce computers. And so we're using 0 hours in the production of wheat. Now, if we do that, if one computer requires 100 hours of labor, then 50,000 computers will require just 500 hours of labor, or 50,000 computers, 50,000 hours, sorry about that, 50,000 hours would produce just 500 computers and 0 tons of wheat. Okay, that's great. Okay, so if I used all my resources to produce computers, I can get up to 500 computers. Now let's say we divide it up in different fractions. So let's say that in scenario B, we're using 40,000 hours of labor hours to produce computers and 10,000 hours to produce wheat. Note that if you add those two numbers up, you still have 50,000 hours of labor. So we have 50,000 hours of labor available. We're using 40,000 hours to produce computers and 10,000 hours to produce wheat. So if we use 40,000 hours to produce computers and one computer requires 100 hours of labor, then we can produce 400 hours of 400 computers and 1,000 tons of wheat. Similarly, if we are in scenario C and we're using 25,000 hours to produce computers and 25,000 hours to produce wheat, in total we're using 50,000 hours and we're dividing up the time equally between computers and wheat, then we can produce 250 computers and 2,500 tons of wheat. Similarly, for scenario D, we're producing, if we use 10,000 hours of to produce computers and 40,000 hours to produce wheat, we're going to make 100 computers and 4,000 tons of wheat. Now, if we used all our resources to produce wheat and none for computers, we would be producing at 5,000 tons of wheat and 0 computers. So now we have our production. So if I'm a policymaker and I look at this, I know that if I have 50,000 hours of labor available, I can use different amounts or different combination of amounts and produce different amounts of computers and wheat. So this is nice. So now if I wanted to actually look at graphically, I mean, looking at a table doesn't give us much insight. So if we wanted to look at it graphically, we have to plot it on a graph. So for point A, we are just down there. The blue point tells us that we are producing 0 tons of wheat, but we're actually producing 500 units of computers. If we wanted to plot point B onto this graph, we are producing 1,000 tons of wheat, or we're producing 400 computers. Notice that it doesn't matter if the wheat is on the vertical axis or the computers on the horizontal axis. I could have actually switched. I could have put computers on the vertical axis and wheat on the horizontal axis. As long as we can see a trade-off going on, and we know that if we can plot the computers and wheat on the graph, it doesn't matter what axis we label as computers or wheat. So for number C, we know that the number of computers being produced is 250, and the number of wheat that is being produced is 2,500. For point D, it is 104,000. So we're producing 100 tons of 100 units of computers and 4,000 tons of wheat. And for point E, we're at 5,000 tons of wheat are being produced if we produce 0 computers. Now we have all these points, and if we draw a line from that, we can see the different combinations of computers and wheat that we can produce in this economy using the limited amount of resources that we have. And this is known as the graphical representation of these data points, and is known as production's possibilities curve. So from the PPF, what do we know so far? Points on the PPF like A, B, C, D, E that we just plotted, they're all possible. That's the maximum amount that we can produce. So if we used all 50,000 hours of labor available, we can produce anywhere on that line. It is an efficient point because all resources are being fully utilized. I'm using all my 50,000 hours of labor available for production. None of it is being wasted. However, the points under PPF, you can have a point like F under the PPF that is below point A through E. A point like that, it is possible, but you're not using all your resources to produce. Because some of the resources are being underutilized, you're not producing everything. So you have workers being unemployed, you have factories being idle. So those points are not, they're possible, but we don't want that because we already know resources are limited. So we want to use our resources to the best possible way. If a point is above the PPF like G, then those points are not possible because we don't have enough resources to produce them. And so they are not possible at this point in time. Another thing that I would like to point, okay, let's go back to the graph. Okay, if we have this line here, okay, what else can we denote from here? So we can actually get a lot of important things from this line. Let's see if I can do pointers. If I'm at a point here, like a point, if I call this point F, okay, I'm not using all my resources. So basically, if I am at point F and if I'm a policymaker and I want to improve my economy, I could make sure that, all right, either people produce more wheat, holding computers constant, or they could produce more computers, holding wheat constant, or they could increase both computers and wheat. So I need to take steps based on what I want to produce more in order to fully utilize all the resources available. Okay, so in the case like or in the case, let's say we are already at point D here, and we're producing here. If the economy gets a shock, like what we saw in the financial crisis, a lot of people were made unemployed. It would mean that the economy is moving downwards here. We're not using all our resources, so people are getting unemployed, and our maximum potential is not being produced. So to stop that, the government needs to do something to stop this flow so that we go back up to the line, somewhere on the line. Another thing that is interesting to see, if this is the economy, we can choose where we want to be. Some economies are very agriculture-centric. They want to produce more up here because they feel like they need more agriculture products. Some economies are down here. All they do is produce machineries and equipment, and they don't produce much agriculture. Like countries like Singapore and Japan are down here, whereas countries like Egypt are up here. But then there are also countries that are somewhere in between. They produce some combination of both agriculture and computers for production. And countries like the US are like that. So all these things we learned from the production's possibilities frontier. So even a simple model like that can help us get a valuable insight about the world where we live. Now, the next concept comes to production possibilities curve and opportunity cost. So the opportunity cost that we learned from last chapter is how much do we have to give up in order to get a certain item. So if I want to produce more of one product in this economy and less of the other, supposing I want to produce more computers and less wheat, that means that I have to move production from one good to the other. So I need to move resources, or labor in this case, from the production of wheat to the production of computers. So in this case, the society is facing a trade-off. If I want more computers, I can't just get more computers. I need to give up the production of something else, excuse me, in order to get more computers. And in this case, if we are on the production possibilities curve, the slope of that line will tell us the opportunity cost of one good in terms of the other. So if we look at this, the slope of the line back from calculus, it's basically rise over run. So it is how much extra tons of wheat in this case can we get if we give up the production of one computer. So it's, since we just have two products in this economy, that is the opportunity cost. What is the opportunity cost of wheat? It is how much computers I have to give up. Or what is the opportunity cost of a computer? It is basically how much tons of wheat do I have to give up. So the slope here is, if I give up 100 computers, I get 1,000 tons of wheat. So the slope is negative because it's downward sloping, so it's negative 10. So it's telling us that the opportunity cost of a computer is 10 tons of wheat. This is one way of calculating the opportunity cost. Another way, if you wanted to look at it, is we know that the production technology is, if you produce 1 ton of wheat, you need 10 hours. Sorry, my handwriting's horrible. Now, if you produce 1 computer, you need 100 hours. So let's think about it this way. If I gave up the production of 1 computer, so I'm not producing 1 computer, I'm producing 1 less computer, I free up 100 hours. So if I'm freeing up 100 hours, in that 100 hours, how much wheat can I produce? Since 1 ton of wheat requires 10 hours, so in 100 hours, I can produce 10 tons of wheat. So then the trade-off between this is basically I can produce either 1 computer or 10 tons of wheat. So the opportunity cost of 1 computer is, how much ton of wheat do we have to give up? It is 10 tons of wheat. So you could use either way to calculate opportunity cost. If you like graphically, you can draw the graph and do that. Or if you want to use just using technologies that we did, 1 ton of wheat requires 10 hours, 1 computer requires 100 hours of labor. Then what's the trade-off between a computer and wheat? Well, if I give up 1 computer, I free up 100 hours of labor. With that 100 hours, I can make 10 tons of wheat. So you can try this exercise. Japan has 30,000 hours of labor available. Producing 1 computer requires 125 hours of labor. Producing 1 ton of wheat requires 25 hours of labor. So you can try to construct Japan's production possibilities curve. So Japan has 30,000 hours of labor available. Producing 1 computer requires 125 hours, so you need to find out how many computers can Japan produce in 30,000 hours. You need to figure out how many tons of wheat can Japan produce in if each ton of wheat requires 25 hours, and then draw the production possibilities curve. And from that, find out what is the opportunity cost of producing 1 unit of computer for Japan. And I'll post the answers in the end. So here we have Japan. Japan has enough labor to produce 240 computers. or 1,200 tons of wheat, or any combination in between. So your production possibilities curve for Japan should look something like this. If computers is in the horizontal axis, wheat is in the vertical axis, you can switch it. It's okay, no problem. But this should be 1,200, and this should be 240. Sorry, my 4 is a little funky, but you should have those numbers. Now, so far we considered the PPF to be a straight line, but the PPA can also be bowed, kind of like this. So if you have an economy that just produces beers and mountain bikes, you can either be intoxicated the whole time or you can be very fit. We may have problems switching from one production of one product to another. PPF can get steeper as we move away from production of, let's say, beer towards production of mountain bikes. Now, why could that be? Or why could that happen? Well, let's think about this point. So if I'm up here, supposing I'm using the best beer craftsman to make beer. Now, at this point, I have great beer like Guinness and other craft beer, but I'm also making very crappy beer like Natural Light and Keystone Light, things that are just awful. So from this point, if I actually start saying that, all right, we need to produce more of mountain bikes and less of beer, as we are going down this way, supposing here, is we're giving up production of beer by that much, but in effect, we're getting a lot more mountain bikes. This is because, the people who are moving away from production of beer to production of mountain bikes are probably the ones that are making the crappy beer, like Coors Light or Natural Light or PBR, you name it. But as we keep on focusing the economy to produce more of mountain bikes, after some point, we'll have our best beer craftsmen to leave the production of beer and join the production of mountain bikes. So we're going to have to give up that much beer production and get only a little bit of mountain bikes. And why is this? Well, because there's for certain kinds of jobs, some people are just good at certain kinds of jobs. There are probably some beer makers who are just really good at beer making. If you tell them to make mountain bikes, they won't be good at it. So each person that we believe in economics has a certain set of skills. Okay, for example, I cannot play any kind of musical instrument. I suck at it. So to me, even if you tell me that, all right, you have 3 years to learn how to play the guitar, I would probably still suck at it. So there are some people who are just naturally inclined in certain production. So a person may be naturally inclined to producing beer. Now, if you make that person produce mountain bikes, that person won't be as efficient in the production of mountain bikes. So when we have the PPF as bowed shape like this, and when we ask more and more good beer producers to produce mountain bikes, yes, we will get more mountain bikes, but at the margin, we're going to get lesser and lesser amount of mountain bikes. So as we divert resources from the production of beer to the production of mountain bikes, increasingly the opportunity cost of mountain bikes will keep on going up because we need to devote more and more resources to produce mountain bikes if we keep on producing more and more mountain bikes. So let's say, in another word, how this is happening at point A, most workers are producing beer, even those that are better suited. So if you want to move from A to the other point, let's say B, then you don't have to give up much beer, but you get a lot of mountain bikes. Now we come to the topic of what's the difference between micro and macroeconomics. So microeconomics studies individual decisions. How does an individual household, an individual firm makes their decision when they interact with their market? So if I go to the grocery store today to purchase grocery, that's a microeconomic decision. What should I purchase? How much should I purchase? How much should I spend at the grocery store? All those are microeconomic questions. If a firm wants to decide how much they want to produce, that's a microeconomic question. On the other hand, the collective decision of all the buyers in a region is macroeconomics. So macroeconomics studies economic-wide phenomena like inflation, unemployment, and economic growth. So things that are affected collectively. So one example is, for example, I just moved to North Carolina last year, and so I was like, all right, well, my decision to move to North Carolina was basically an individual decision. I got a job here, so I moved here and I started living here. So when I moved to North Carolina, I had to get a new house. I had to um, get groceries, and so one extra person entering the economy didn't really change the whole dynamic of the North Carolinian economy. So that's a microeconomic decision. I moved because I got a better job, so I moved to North Carolina. On the other hand, if let's say 500,000 people move to North Carolina just like me in a given year, now that would create some issues. The government now needs to make sure that there's enough electricity being produced, that the property managers needs to ensure that there are enough housing for the people. So all those then becomes macroeconomic questions. So individual decisions collectively can affect the macroeconomy. So each of us may have a different reason why we moved to North Carolina, but collectively they do have a lot of effect on all the other people living in North Carolina. So now the farmers have to grow more food in North Carolina. The roads have to be widened to accommodate the extra cars. More houses need to be built. So all those things then affect unemployment level and economic growth and inflation in North Carolina. These two branches are different, they're distinct, but they do affect each other. So whatever individual decisions does have an effect on the macroeconomy, and then the macroeconomic problems does have an effect on individual decisions. The last thing we're going to talk about is the economists, the things that we do. As scientists, the economists make positive statements, which is basically facts. So if I say that I am right now talking to you guys through a recording device, that's a fact. You cannot change that. Or if I'm saying I'm wearing a blue shirt, that's a fact. Nobody can say, no, you're not wearing a blue shirt, you're wearing an orange shirt, because no, I know this is the color of blue, so this is a blue shirt. That's a fact. However, as policy advisors, economists also make normative statements which attempts to prescribe how the world should be. So, as positive statements, as scientists, economists make, all right, this is what the economy looks like right now. As policymakers, we try to say, no, this is what it should be. So, po positive statements can be confirmed or refuted. I mean, you can say that, all right, well, okay, the unemployment rate in the US currently is 6%. Well, that's a fact. You can either say, no, it's not because, look, I collected this data and I did all this thing, and here is my evidence of that. But what the world should be, that's individual decisions and that's individual choice. So it's basically what I think the world should be. If I think that everybody in this world should have free housing, that's my individual decision. And that's a normative statement. If I say that in America right now, 50 million Americans are, are poor, that's a positive statement, not positive as in it's a good statement, it's positive as in it's a fact. That's how many Americans are living in poverty. Now, the normative statement would be, all right, well, we should improve their education system so that the poor get better education. Okay, well, another person might think that no, education won't help. We need to improve the community. We need to lower crime. Or another person might be like, no, we just need to provide jobs. So normative statements, different people can have different normative statements. Okay, there is no one fact in that. It's basically how we want the world to be. Positive statements is basically what the world is at this moment. So as economists, we tend to handle both these statements and we tend to address both these issues. Well, that's all we have for chapter 2. Hope you have a good rest of the day, and we're going to meet again for chapter 3.